In this lesson, we're going to continue focusing on the concept of area under the curve and using Riemann sums method. However, we're now going to focus on tables, which I think tables are going to be a little bit easier than the graphs because you can only use the values that are given to you in the table. So here, for example, we're focusing on an increasing function here with the water that's being pumped into a tank over time in minutes. And then here from 0 to 12. So we're going to use our Riemann sums to estimate the number of gallons of water that are pumped into the tank after 12 minutes. So we're focusing on the entire table, right? So after 12. Now, same thing, we focus on just like before, right? We need the width. Well, the width was always from the x. So notice the width is 3, 3, 3, and 3. Now, check because this one is nice where they're all the same. However, in some cases, they're not going to always be the same. So that's why it's good practice here. So we are going to focus on with the right sum theorem, right? So with the right sum theorem, that was when we focused on the right side of the interval. So in this case, it would be 3 times the right side of the first interval is 13. So 3 times 13, then plus 3 times. So the right side here is 18 plus 3 times 23 plus 3 times 27. These are all values that would represent the right side of the subinterval. Multiply, add them up, and you get 243 gallons. Now keep in mind, is this approximation greater or less than the true value? So if you recall, and if you need to, because we discussed this in the previous lesson, whenever we're talking about an increasing function and using the right Riemann sum, then this approximation is going to be greater. So it's greater. Why? Because we're using the right Riemann sum theorem or right Riemann sum on an increasing function. And again, if you need that visual as a reminder, if I were to do a quick sketch, right? I've got an increasing function. And if I were to use the right sum, so here to here, let's say is my interval. And if I use the right sum theorem on an increasing function, see, notice again with that visual that this represents greater than. So now let's go ahead and let's do the left side. So how about you go ahead, same thing, set up, how would you solve, and let's see what you get for the left Riemann sum. And here we go. So here, same thing, the width is 3, but 3 times 7 now, right? Because the left side of this first subinterval is 7. Then plus 3 times 13 plus 3 times 18 plus 3 times 23. All these values represent the left side of each of your subintervals, giving you 183 gallons. Now, is this approximation greater or less than? Less than, because now we're using the left Riemann sum on an increasing function. And again, if you wanted to see that quick visual, right? So let's say we have our subinterval that's from here to here. The left on an increasing function, notice is less than the true value. So now we're going to use the same table here, but now using midpoint with 2 subintervals. So we are only now focusing on 2 subintervals. So if I were to take my table and we would go from here to here and here to here. So notice the width in this case is 6 and the width is 6. Then here, remember, so the width is 6, but then times the midpoint. Well, notice, do we have the midpoint? Absolutely. The middle of the first subinterval is 13, right here. So remember, we always use the y value. That was your height. So here we're at 6 times 13 plus, so what value represents the middle here that we would also multiply by 6? 23. That is the middle, the midpoint. So in this case, we're at 216 gallons. And here we're going to focus on using the trapezoidal sum with 4 subintervals. So again, going back to each of our 4 subintervals with a width of 3. But then now remember, the trapezoid, you had to use both of the heights and find the average. So for the first interval, this is 3 times the 2 heights, which are 7 and 13, 7 plus 13, and find the average. So again, plus 3 times the average again for the next, which is 13 plus 18. Divide that by 2. We're finding the average of the 2 heights. Plus, so 3 times 18 plus 23, divide by 2. Oh, running out of space, sorry. Plus 3 times 23 plus 27, divide by 2, we're finding the average. So in this case, you end up with, and however you want to simplify and put this in the calculator, practice. So if you need to, pause the video before I give the answer. But you should get 213 gallons. And keep in mind, out of the 4 methods that we just used, which would be the most accurate? The 213 gallons, because that's with your trapezoidal sum. So here, now this is focusing on the rate of change of a population over a 20-year period. So here we go, 0 to 20. Where y here represents our people per year and differential function, increasing function. So again, we're increasing. We're going to use the table to, we're going to use the data from the table and find using a right Riemann sum with 4 subintervals. So n is equal to 4 to approximate the area under the curve from 0 to 20. So we're focusing on the entire section here. So again, we need the width. So here's 4. Oop, but notice this is 6. Notice that this subinterval is 3, and the 4th subinterval has a width of 7. So notice they're not all the same. Now, keep in mind, we're still going to use the right Riemann sum theorem. So like for the first subinterval, what value are we going to use? 2,724. So the width is 4 times the height, which is 2,724, because that's the right side. Then here, that means for the next, we're going to use the width, which is 6. 6 times, what's the right side? The 3,108. Then, sorry about that, not 318, 3,108. Then for our third subinterval, the width was 3. So 3 times, what is the right side? 3,697. Then plus the width, which is 7, times the right side, 4,283. So again, practice putting all that in the calculator, and you should get 70,616 people. That is the area under the curve. So let's do the next one. Here, we're focusing on the customers being served at starburst given this continuous function from 0 to 10. Now keep in mind that where t was at 0, they had already served 200 customers. So keep in mind. So even though we've got this table here, they already had served 200. We're going to use a trapezoidal sum for 4 sub-intervals. So again, 1, 2, 3, and 4. To approximate how many customers had been served after 10 hours. So again, 0 to 10. So here we got a width of 2, a width of 1, a width of 3, and a width of 4. Now, keep in mind the trapezoidal sum, right? So for the first, find the area of the first subinterval. The width is 2, but then trapezoid. So we need to find the average of the two heights, divide by 2. So here the two heights are 37 and 44. So then plus, the next would be 1 times 44 plus 36. Find the average, so divide by 2. So go ahead and pause and finish the setup, and then let's see what you get. How many customers had been served? So how many customers had been served after 10 hours? And let's see. So here you should have finished plus. The next subinterval had a width of 3 times 36 plus 42 divided by 2 plus the last subinterval had a width of 4 times 42 plus 48 divided by 2. When you simplify, you get 418. However, does that mean that that's how many customers were served? 418? No, because remember, at t is equal to 0, they had already served 200 customers. So how many customers had been served after 10 hours? 618 customers. Don't forget that 200 that were served before the start of the collection of data here. So go ahead and pause the video and try this one on your own. And here we go. So here you're talking about weight loss on Biggest Loser for a contestant each week here. And you had to use the data from the table and a left Riemann sum with 4 subintervals. Sorry, the question got, you're finding the approximate area under the curve. So we are focusing on 2 to 11. So here we've got our 4 subintervals. You should have identified the widths were different at 2, 3, 1, and 3. So here, using the left Riemann sum, so for the area for the first subinterval, this is a width of 2 times 14, because that's the value now here on the left, plus 3 times, then the value on the left is 12, then plus 1 times 18, plus 3 times 14. Then here, when you simplify, you should get an area of 124 pounds.